All right, you guys, this calculation is going to kind of blow your mind. I think it's really important that we as citizens and especially as scientists really think long and hard about the potential impacts of new discoveries. And, had we, when the combustion engine was first developed, really thought and tested what the impacts would be from massive increases in the amounts of carbon dioxide put out into the atmosphere, maybe we wouldn't be in the situation that we're in today, which is at this point where if we do not massively curb the amount of CO2 we're putting out into the atmosphere, there are going to be irreversible changes to our climate. And so I think this one simple calculation is a really stark example of that, and I think it's going to surprise you. And I hope it inspires you as future scientists and, citizens and maybe legislators or political activists to really try to be a voice in your particular community to think about all angles of something, even if that something seems like really great at the outset. Like, man, Twitter and Facebook seemed really great at the outset. And, a couple years down the road, we see that these are tools that can be used to propagate misinformation. So, let's try really hard to think about things from many, many different angles, both when they are first, discovered and implemented and as we continue to use them as a society. So here we go, stoichiometry and the environment. The average car in America has a 12-gallon fuel tank. Now, obviously, we're seeing a lot more electric vehicles on the road, which is awesome. But if you're driving, your standard gasoline-fueled car, you've probably got around a 12-gallon tank on average. And when you fuel up your car, you're fueling it up with a mixture of things, but it's primarily octane. And so we're going to write the balanced chemical equation for the combustion of octane, which is what, in fact, is happening in the engine of your vehicle. Again, there's other things in there like ethanol and some stabilizers as well. But let's just, for now, use octane. Octane is C8H18. That octane is combusting, and we know that a combustion reaction is a reaction with oxygen to produce, always, CO2 and H2O. Again, neither of those toxic, but both of them greenhouse gases. Okay, now, of course, the complete combustion produces pure CO2. Obviously, when you're running your car, you're also producing some carbon monoxide, which is toxic, right? So a reminder never to warm up your car inside of a closed space like a garage. Of course, you wouldn't want to be running your car for no reason anyway, right? Because you're putting out CO2 and you're not going anywhere, so that's bad. And some of you might have carbon monoxide alarms in your house if you have like oil heat, because when you're burning stuff, if you don't get complete combustion, you can also get some carbon monoxide as well. All right, that was a side note. Let's balance this equation, because to do stoichiometry, we need a balanced chemical equation. So I'm going to need an 8 out here in front of my carbon dioxide. I need to get to 18 hydrogens, so 9. Let's count up all my oxygens. 8 times 2 is 16, plus my 9 oxygens over there. So that's 25 oxygens. That's a lot. So I'm like a 12.5 right there. 12.5 times 2 equals 25. Now, if you don't like that, 12.5 right there, you can multiply this whole thing through by 2. Doesn't matter. So you can either leave it as 12.5 or multiply everything through by 2. I'm just going to leave it because, I'm okay with that. And in AP chemistry, we're going to balance things with halves all the time. Okay, now the question is asking, if you burn 1 tank of fuel in your car, calculate the mass in pounds of carbon dioxide that you have emitted out into the atmosphere. Okay, so let's put our known and our unknowns on our balanced chemical equation. So we're going to burn 1 tank of fuel. And so the fuel here is octane. So if I burn 1 tank of octane, the question is, how many pounds of CO2 is that in the atmosphere? Let's start with our known value. Let's start with the 1 tank. I know that 1 tank on average, and listen, you could plug in whatever your fuel tank size is. 1 tank is 12 gallons of gasoline. I'm going to convert my gallons into liters here because I'm going to need eventually to get into a mass value of octane so that I can get into moles of octane. So I'm going to use my gallon to liter conversion. So 1 gallon is 3.79 liters. Okay, so now I'm in volume. I'm in volume and I need to get to moles. But I can't use 22.4 liters because it's not a gas, it's not an STP. So I'm going to need to use density, right? I'm going to go from volume to mass by using the density of the octane. And this density is in milliliters. So let's convert these liters to milliliters. 1 liter is 1,000 milliliters. And now I can use my density, 0.702 grams. And here's when I should probably start using my substance of octane for every 1 milliliter of octane. Oof, so that was a whole bunch of work just to get into mass of octane. And now I'm in a pretty similar situation as I would be in with any of these Stoich problems we've been doing, where we go from mass of one thing to mass of another. So I need to get into moles of octane. 1 mole of octane has a molar mass of, let's see here, 8 times 12 plus 18, 114 grams per mole. Now here's the kicker, you guys. Like, this is why combustion is really a problem. For every 1 mole of octane that I burn, I'm producing 8 moles of CO2. Like, it produces a lot of carbon dioxide for every 1 mole of octane that burns. Let's convert those moles of CO2 into mass. 1 mole of carbon dioxide has a molar mass of, I think it's 44. 16 times 2 plus 12. Yeah, 44 grams per mole. And lastly, let's turn these grams into pounds. There are 454 grams in 1 pound. All right, you guys. Let's calculate how many pounds of CO2 that is. Oh my goodness. My screen just blanked out. Hopefully you didn't see that. 12 times 3.79 times 1,000 times 0.702 times 8 times 44 divided by 114 divided by 454. Do you guys believe me? Are you calculating along with me? 217 pounds of carbon dioxide. You burn 1 tank of gas and you're putting out over 200 pounds of carbon dioxide into the atmosphere. Hopefully that surprises you and inspires you to do a little carpooling. Maybe consider an electric vehicle when you're old enough to pay for and choose your own car. Okay? So I do that, you guys, to highlight for you the importance of really thinking about not just new discoveries, but thinking about all things from as many angles as we can. And sometimes those conversations are difficult, and sometimes they require a lot of compromise. But the point is that there are consequences to everything that we do here on Earth. And we should really think about and know the facts before we make decisions as a society for what we're going to do about it. All right, good job today. I'll see you on the flip side.